Good evening, everyone. Welcome back to day 3 of our FDP on artificial intelligence and machine learning. So, in the previous sessions, we have understood the topics of Python, right? So, in which we have covered all the fundamental topics, like we understood the history of Python, then followed by the features. Next to features, we understood the concept of variables, right? Then we have discussed the ground rules, how we have to declare a variable in Python, right? Then we understood the important topic. It is data types. Data types were being discussed. Next to data types, we have also understood operators, right? Next to operators, we discussed flow control statements. Flow control statements in which we have discussed, we have understood the concepts of conditional statements, looping statements, as well as we have also discussed miscellaneous flow control statements. Right. So we have discussed all these topics. And the last topic that we have discussed under Python is functions. So guys, if you are joining for the first time, okay, just go back through the previous 2 sessions in which we have understood Python topics. All these fundamental topics were being covered. If you understand these fundamental topics, probably whatever we are going to understand from today, for implementing the topics that we are going to learn from today, we'll be using Python. Implementation will be done using Python. Got it? Yes. So let me start with a new topic. It is crisp-mlq. Before I explain what exactly is crisp-mlq, let me fix the agenda. In today's session, we are going to understand how analysis to be done on the raw data. How we have to perform analysis. Nothing but we are going to understand data analysis as well as data visualization. So today the topic will be very interesting, where we will be understanding the concepts of statistics. Okay, so we'll go back to our schooling days, probably where we have understood the small topics, very basic topics like mean, median, mode, variance. So all those topics we are going to understand, as well as under visualization we'll be understanding the topics of the concepts like bar plot, histogram. So probably today it will be very interesting, friends. Okay, so pay attention, and as well as we are going to understand a new project management methodology called crisp-mlq. We'll be understanding a project management methodology called crisp-mlq. So that will be the agenda for the day. Let me start with crisp-mlq. What exactly is crisp-mlq? crisp-mlq stands for cross-industry standard process for machine learning with quality assurance. I repeat, cross-industry standard process for machine learning with quality assurance. So basically, if I want to build any AI application in real time, what we do? We have to follow methodologies. Any project, there should be a methodology. A project management methodology has to be followed. And we blindly follow crisp-mlq. I hope you are getting the point. So if there is no kind of methodology, if there is no kind of flow, our work will not be completed. We'll move here and there. But to be honest, no, we're not going to accomplish the task. So we generally follow a methodology, and industry widely uses crisp-mlq, guys. Okay, so in crisp-mlq, there are in total 6 phases. There are 6 phases. What are these 6 phases? The 6 phases that we have in crisp-mlq are, I'll keep it here: business and data understanding. Business and data understanding. The first phase is business and data understanding. We'll understand. Okay. Second phase is data preparation. It is data preparation. Then what about the third phase? Third phase is model building. Third phase is model building. Okay. What about fourth phase? Model evaluation. Model evaluation. Then fifth phase, model deployment. And the sixth phase is monitoring and maintenance. So these are the 6 phases that we have in crisp-mlq. I repeat, the 6 phases are business and data understanding, data preparation, model building, model evaluation, model deployment, and monitoring and maintenance. So let us understand step by step. Let us understand each phase one by one. What exactly is business and data understanding? What exactly is business and data understanding is we understand the client's business. So are we actually understanding what exactly the client does? Yes. Apart from understanding the business, we'll understand the problem. See, when a client approaches us in general, if they have a problem, so we listen to the problem that the client has. We listen to the problem that what exactly our client is facing. Okay, we'll understand this business problem. Then, post understanding the business problem, we'll also understand the data. We'll also understand the data that is provided by the client. So that is what we exactly do in business and data understanding. Coming to data preparation, the second phase of crisp-mlq, it contains 3 subphases. There are 3 subphases in data preparation. Okay, so what are these 3 subphases are? The first phase in data preparation is EDA. EDA stands for Exploratory Data Analysis. So what does it mean? We are performing analysis on the data, okay, where we get the insights. So we'll perform the analysis on the raw data to get insights. Then post completing EDA, we'll perform data cleansing. We'll clean the data, guys. Post performing EDA, we'll go and perform cleaning. If the data has any duplicates, we'll remove the duplicates. If there are any outliers, we'll remove the outliers. So in this way, we'll clean the data. We'll understand what are these cleaning steps. We'll understand next to EDA. And finally, we perform feature engineering. It is nothing but client may provide n number of features, n number of columns. Yes. When the data that was provided by the client, it contains both rows and columns, obviously. So the data can contain both rows and columns. So these columns are nothing but features. We perform a kind of engineering on the features where we perform feature selection, feature extraction, that we do as part of feature engineering. So that means what exactly are we doing? We are preparing the data. That is why the phase is named as data preparation. Why am I preparing the data? The reason why am I preparing the data is to build a model. Sorry, what exactly is model? Model in short is represented as a mathematical equation. It's represented as a mathematical equation. So if you use the concepts of machine learning or deep learning, okay, which are subset of AI. Okay, these are the branches that are subset of AI. They help us to predict the future. Right? See, if I want to forecast what will be the temperature at a certain location, at a specific location, can I forecast the temperature? Yes. Can I predict whether it will rain tomorrow or not? Yes. But how? When I build this model, I will be capable of predicting, forecasting the future. That is what we exactly do. Using machine learning or deep learning, we'll have the algorithms. Using these algorithms on the data will give us a model. So that model will be built, as part of phase 3. So in short, a model is nothing but an equation, a mathematical equation in which X represents inputs. Inputs. X represents input features. Y represents output feature. Your target column, your label column. Okay. So if I take an example, like whether a student will pass or fail. If I want to come up with a model which help us to predict, whether a student will pass or fail. So the column in which we have pass fail values will be our target column, output column, Y column. I hope it is making sense. So this is what we build at the end. But the model that we build should also be evaluated, right? See, you cannot just blindly build it and give it to the client. Am I right? You have to check the performance. So we evaluate the performance of the model in phase 4. We evaluate the performance of the model. So there will be some metrics. Using these metrics, we evaluate the model performance. Like accuracy, error. Okay. So these are some of the metrics that are generally used to evaluate a model. Then once if the model is performing well, okay, after evaluation, I came to know that the results are very good. Then we blindly deploy it. We'll deploy to the production so that the client will start using it. Client starts using it post deploying the model. So in deployment, after deploying the model, I can use this model. Using this model, I can predict the future. By passing all the inputs to this model, what am I going to get? I'll get output. That is how we will predict the future. We are forecasting the results. I hope it is making sense. And finally, monitoring and maintenance. Post deploying will not just rub our hands. No, we are not done yet. We'll monitor the model's performance. We'll continuously monitor the results. How the model is performing on the new data. If it is performing good, If it is maintaining the results, fine, accept it. If it is not maintaining the results, the output is not, till the mark, then we do maintenance. Then we do maintenance for the model. That is nothing but we'll take the new data as well and we'll again train the model. Okay, with the new data, again we'll go back to this step. Okay, then we'll evaluate it and that new model will be deployed. So this is a continuous journey. And these are the 6 phases of crisp-mlq, guys. I have given you the overview of crisp-mlq. Okay, so whenever you talk about a project in machine learning or deep learning, especially AI, there should be a project management methodology that has to be implemented, and we go with crisp-mlq. And today we are going to understand, this part. EDA, Exploratory Data Analysis. How analysis has to be performed on the data to extract the insights. Then, as part of EDA, there are multiple subphases again. There are multiple moments. We'll calculate each and every moment. We'll get the insights. Okay. Then we'll also visualize the data. Data visualization is also a part of EDA. So today we are going to learn the concepts of EDA, Exploratory Data Analysis. I hope it is clear. Now, let me start with, excuse me. So here we have the agenda. So under EDA, there are in total 4 moments. There are 4 moments. What are these 4 moments? First moment, business decision. Second moment, business decision. Third moment, business decision. Fourth moment, business decision. Okay. Then next to these 4 moments, we have graphical representation. So under graphical representation, we have multiple plots that need to be understood. What are they? Histogram and bar plot. Box plot is the other visualization. So each and every visualization has a purpose. There is a purpose behind visualizing these plots. We'll understand it one by one. Next to box plot, we'll understand QQ plot. And finally, scatter plot. Okay, so all these topics we'll understand theoretically as well as we'll also focus on hands-on. We are going to focus on hands-on. So I'll be taking a data set which is open source. Okay, so any one of you can download it and start using it. So we'll be implementing whatever we have learned on this data set as part of hands-on. I hope it is clear. Now let me start with the first moment business decision. What exactly does this first moment business decision give us? Is as part of first moment business decision, we'll get the center value. We are going to get the center value. Okay. If there is a data set, guys, assume that there is a data set. Okay. So this is the data set that I have. Okay. In which there are features, columns, and there are also rows. Okay. So if you take this data and if you are going to take one specific column alone, and if I ask you what is the center value, in general, what do you see? Or I'll just give the best example. Assume I'm a student. Okay. And I have recently given my 10th exams. Okay. So I'll get all the marks. Yes, obviously I'll get the marks for Telugu, English, Hindi, so on. Okay. I have given exams for 6 subjects. So I'll get all the marks for all the subjects. Now, if you take all these 6 values, okay, so let me keep the values as well. In Telugu, I got 90 out of 100. In Hindi, probably 85. Probably in English, just 80. Then Maths, 95. Okay. Then Science, let me keep it as 90. And finally, Social, I keep it as 88. So these are the marks that I have secured out of 100 in each and every subject. If you take these marks and if someone asks you, what is your center value? In general, what do you see? How you are going to calculate it? Are you going to tell all the marks? Not exactly. What we do, we represent the center value with average mark. We represent the center value with the average mark. Am I right? Yes, that is what we do. So if someone comes and asks the percentage, you're going to calculate the center value only, right? So that center value is calculated using average. So in short, the average is giving us the center value, and this center value will represent the, entire data. See, if I say I secured 90 or 85 percentage, if my average mark is 85, that doesn't mean I secured 85 in all the subjects. No. See, did I secure 85 in all the subjects? No. 85 is my average mark. There are subjects where I have scored more than 85, and there are also subjects where I have scored less than 85. Right? So, but what is 85? 85 is my representative value. It is representing my marks. It is representing my marks. So, first movement business decision will give us the representative value. You take any data, any column data, if you want to calculate the representative value, how you are able to do it? Using first movement business decision. It is also known as measure of central tendency. We calculate the center value. But how we are able to calculate the center value is we have measures. We have some measures. It is nothing but mean. What is mean? Mean is nothing but average only. What is the formula for mean? Average. How is average calculated? Sum of observations by total number of observations. Right? Yes. Sum of observations by total number of observations will give us the mean value. Yes. Here we have the formula. Mean is nothing but the average value. But this mean has a disadvantage. You know what is the disadvantage of considering mean? Mean is sensitive to outliers. What are these outliers? Outliers are nothing but extreme values in the data. If there is any extreme value, assume I have secured only say 50 marks. I have just secured only 50 marks in a subject. If you compare this 50 with other marks, will it be an outlier? Will it be an extreme value? Yes, it is an extreme value. So extreme values in the data set are called outliers. And because of these outliers, the mean value gets influenced. The mean value gets affected. Let me take a small example. Instead of taking a big numbers, I'll give a small example so that you'll understand well. If you have data in this fashion, guys, 1, 2, 3, 4, and 5. And if I ask you to calculate mean, what you do? Obviously, you'll use the formula. Yes. So, mean is equals to sum of the observations. 1 plus 2 plus 3 plus 4 plus 5. It means 15. Divided by number of observations are 5. So, this will return me 3. So, 3 represents the entire data. 3 is my center value. The representative value for this data. Fine. Accepted. In the same data, if there is an outlier, see what's happening. Instead of 5, if you have a value like 50, if there is a value like 50, okay, now calculate mean and let me know. 1 plus 2 plus 3 plus 4 plus 50, it is nothing but 60 divided by 5. Is it 3? No, it became 12. It became 12. The original value should be 3. Just one value got changed because of this what happened? It is affecting the mean value. It is affecting the mean value. The average value is getting affected. Because of what? Because of an outlier. So I can clearly understand that if there are outliers in the data, the mean value gets affected. Then how to calculate the center value if there are outliers in the data? There we go with median measure. There we go with median. So under statistics, we have learned mean, median, mode. What is mode? Sorry, what is median? Median is nothing but the middle value of ordered data set. If you have this is the data set, once after ordering it, the middle value will return me no, the median. The middle value will be the median. Even if there are outliers. See, if there are outliers, still the middle value will be the median. So what's happening? I can understand that there is no influence of outliers on the data, on the median value. Even though if I have outliers are nothing but extreme values. So they will be either towards left side or right side. But my median value is the center value. I hope it is making sense. Okay. So when you have outliers, it's always we go with the median as the middle value. We'll go with median measure for calculating the representative value. Fine. What about mode? We understood mean and median because mean having a disadvantage which is sensitive to outliers. Okay. So median is actually overcoming the mean. Right? Median is actually solving the problem that mean has. But what is the purpose of mode? Mode help us to, mode is actually nothing but the most repeated value. The most repeated value in the data is called mode. But what is the purpose of calculating mode is, guys, if it is numeric data, I can calculate mean and median. But what if I have non-numeric data, categorical data? Can I calculate mean? Impossible. Can I calculate median? No. There I go and calculate mode. So mode is the only measure out of entire EDA, not only first moment, entire EDA, which is calculated for non-numeric data. So what can you understand from it? I can clearly understand that apart from mode, rest of all the measures will be only calculated on numeric data. If it is non-numeric column, the only measure that is possible to calculate in EDA is mode. It is mode. But what is mode? Mode is nothing but most repeated value. Whichever value gets repeated for the more number of times, that returns the mode. That value will be written as mode. And mode is of three types, guys. Unimodal, bimodal, and multimodal. What is unimodal, bimodal, and multimodal? Let us understand. Unimodal represents, returning one value for mode. If the mode value that you get for the data set is only a one value, that is an example of unimodal. If two values repeat for same number of times within the data, then it is an example of bimodal. It is an example of bimodal. If the mode values are greater than 2, then it is an example of multimodal. In general, the mode represents clusters, groups. Within the data, if there are any groups, we can understand using mode calculation. See, whatever we calculate, whatever we do as part of EDA, there is a reason behind it. There is a reason behind it. Without the reason, we cannot do it, right? Yes. So mode actually, identifies the groups, the clusters, segments within the data. So I hope it is clear. What exactly we do in first moment business decision? We calculate the representative value, the center value for the data. In order to calculate the center value, we have to go with first moment business decision measures. What are they? Mean, median, mode. Mean has a disadvantage. It is sensitive to outliers. Outliers, because of the outliers, the mean value gets affected. Right? And this disadvantage of mean is actually overcome by median. And finally, mode is for calculating the center value, the most repeated value for non-numeric data. Now, let me calculate these measures. Okay, whatever we have understood so far as part of first moment business decision, let us do calculate these measures in Python. Using Python, let us do calculate them by taking an use case. For that, I have took iris data. Okay, so this is available open source, guys. Let me show you the data set as well. Anyhow, I'll have it here. Right. So I'm going to import a package. I'm going to import a package. What exactly is a package is, within a package exactly represents a folder. Okay, this package represents a folder. Within the folder, we'll have a empty init file. Okay, empty init.py file. Along with this file, we'll also have .py files which are called as modules. Okay, in short, a package is a collection of modules. What is a module? Module represents a single .py file. A single .py file is called as module in Python. Okay, so there is a package called pandas which is widely used in Python. What is the purpose of pandas is, pandas help us for data manipulation. In order to manipulate the data, we use pandas. Okay, I'm going to import pandas as PD. Okay, I'm importing pandas as PD. So that means the entire folder gets imported to the sessions memory. Done. You see here? Done. So import is a keyword, as is a keyword. Pandas represents package name and PD represents shortcut name or alias name that we are giving for pandas. I hope it is clear. Now, using pandas, okay, within the pandas package, there are n number of functions, right? So I'm going to use one of the function. It is read underscore CSV. It is read underscore CSV. What exactly does read underscore CSV function does is read underscore CSV function help us to read the data from a CSV file. Okay, if you have the data present in a CSV file, you can read the data from the CSV file from CSV file to Python's memory. So it should be used in this way. As I have imported the entire pandas, so it will be like pd dot read underscore CSV. You cannot directly use read underscore CSV. The reason is if you import read underscore CSV alone, then you can use it. But did I import only read underscore CSV? No, I have imported pandas. I have imported the entire pandas package. Read underscore CSV is present inside it. So it should be represented in hierarchy. The dot represents hierarchy. PD. What is PD? Pandas. Pandas is no more pandas. Pandas is PD. Okay. So PD dot read underscore CSV. Within the CSV function, we are passing the path. So this is the path at which I have the CSV file. In my local machine, I have this file at this location. And the R in this line represents to read the data. Okay, it is not exactly representing the read. So the R actually tells the PVM that to consider this entire path in the raw format. In the raw format, it is going to consider this entire data. So once after executing this line, the data gets read and the data gets stored in a variable, an object iris underscore data. Let me do it, guys. See, within fraction of seconds, as the data set size is very small, it does not take even seconds. What is the size of the data set? 150 rows, 5 columns. I'll come from here. What is the name? Iris underscore data? Yes. What is the type? Data frame. What is data frame? Data frame is similar to a table. It's a two-dimensional object in Python, similar to table. What do you have in table? Within a table, we'll have rows and columns. So just map it here. How many rows? 150 rows. How many columns? 5 columns. Let me open it. See. So this is the advantage of using spider. From day one, I am telling you, right? If you better start using spider. If you are a beginner, my suggestion will be go with spider. Start practicing using spider so that your understanding will go to the depth. So this is my data set, guys. How many columns? 5 columns. And these are the values. Now, I have also provided the data dictionary. Okay. What exactly data dictionary tells is, it explains it gives the information for each and every column. What is sepal length, sepal width, petal width, and variety. So this data set is related to flowers, iris flowers. Okay. So we have the length and width of the flowers got captured for both sepals and petals, and we have them in column 1, 2, 3, 4, and in column 5 we have the variety of the flower, the type of the flower. Okay, so that is what the data dictionary is giving the information. Now let me start with the shape attribute. So what exactly is this? Iris underscore data is a data frame object. Yes. Data frame object dot shape. Shape is an attribute. This will return me the size, the dimensions of the data set. 150 rows, 5 columns. Again, you might raise a question. Already we have it here, right? Why are we using shape? The reason behind it is, if you are not using Spider, if you are using any other IDE, how you will get the information? This feature is available only in Spider. So there we have to go and use shape attribute. There we go and use shape attribute. Then head function. I'm using head function on the data frame object. See, very simple guys. Python is very simple if you understand. I'm just using the dot, the period. Okay. So it means we are using the head function on the data frame object. What does head function does? The head function will return the top records. The top rows will be returned. But did I specify the number? No. So that means by default 5 rows will be returned. The top 5 rows will be returned. See. Let me expand it. So if you see here, these are the 5 rows. The top 5 rows. 0 till 4. Index is 0 till 4. In the same way, tail function. Head function will return the top rows. Tail function will return the bottom rows. See. 145 till 149. Making sense? Then info function. Info function will return us the complete information about the data set. Okay, when we use info function on a data frame object, it will return us the complete information. Okay, like it is going to return us the number of columns, the column names, okay, the non-null count and the data type. How many columns? 5 columns. How many rows? 150 rows. Their index. Okay, the column names, columns index, then the non-null count. So it is also providing the information about the non-null, whether the values are null or not. Then the D type. Okay, the data type. So in this way, it is going to provide the complete information. Then describe function. Describe function will return the descriptive statistics. Let me execute. Yes. So here are the results for the describe function. But we have 5 columns, right? I see the output coming only for 4 columns. This is because of describe function will actually work only on the numeric columns. It does not work on non-numeric columns. No. It works only on the numeric columns. Out of 5, only the first 4 are numeric. So the describe function will return count, mean. Mean is nothing but, the measure that we have understood as part of first moment, mean, average. Then standard deviation, minimum value, maximum value, 25th percentage, 50th percentage, and 75th percentage. We'll understand these values later on. Not now. After some time, we'll understand these values. Right? So these are the results that will be written as part of describe function. Describe function will return these values for all the numeric columns only. Now, let me start using first moment. I'll start calculating the measures of first moment. What am I doing? In line number 33, I'm using print function. So to print a message, I'm using print function. It will print first moment business decision to the console. Done. Done. Next to it, what am I doing in line number 34? Again, I'm going to print a message mean. Okay, so this print function will print mean to the console. See. Now, I want to calculate mean, the first measure of first movement business decision. I want to calculate mean. So, in order to calculate mean, as we have 4 columns, as we have 5 columns, and we know that mean can be calculated only for the numeric columns, what am I doing is, let us understand the syntax first of all. The syntax is data frame object dot column name dot mean. Mean is the function. So I repeat, data frame object dot column dot mean. So in this way, we can calculate the mean for all the 4 columns. When I execute, within fraction of seconds, it will return me the mean value. See. It has written me the mean value. Then, how should I calculate mean for sepal width? Take the same line of code, instead of sepal length, replace it with sepal width. Your job is done. This is the mean value for, sepal width column. So in this way, I can calculate mean for all the columns. Yes. Again, you may ask me, why didn't you calculate for rest of the 2 columns? This is just an example, right? So I have to do it. EDA means performing analysis on all the columns. Okay. So I haven't done it on the rest of the 2. But when you are working on any data set, it means you are supposed to do on each and every feature, each and every column. Then I want to go with median. So let me get the median results, guys. Print of median. Median gets printed. So in order to calculate median, what am I doing? The syntax is same. Just replace the function. Instead of mean, I'll replace it with median. So this will return me the median of sepal length column 5.8. 5.8. So the ordering will be done and it is also returning the middle value. Let us calculate median for sepal width column. It is 3. It is 3. Then finally the mode calculations, the mode measure. So we know that mode can also be calculated for non-numeric data. Okay, but I'm going to calculate mode for sepal length column. For the sepal length column, let us calculate mode. And what is the mode for sepal length? It is 5.0. So it is an example of uni-model. It is an example of uni-model. Then let us calculate mode for sepal width column. Just change the column name. This will return me, the mode for sepal width column. So in this way, I can calculate mean, median, mode for any given column. Whatever might be the column, the syntax is fixed. When I use the function, I can calculate the respective measure. So did I complete all the first movement measures? Yes, done. Now I'll go back to second movement. First movement is returning me, the center value. The center value was returned by first movement business decision. The representative value, fine. But what about second movement business decision? Second movement business decision, it returns what? Second movement business decision, it measures the spread. It measures the spread. or dispersion or deviation. All these mean same, guys. When I use second moment business decision measures, they help us to understand, the spread in the data, whether there is a spread in the data or not. But spread from where? Spread from the mean value, nothing but the center value. If you take the center value in the data, whether you have spread or not, you will understand by calculating second moment business decision measures. What are the second moment business decision measures we have? Variance, standard deviation, and range. Range is very simple. Okay. Range is nothing but the difference between the maximum value and the minimum value in the data set. So this will return me the range of the column, the range of the data set. Coming to variance. Variance returns the average squared spread. Okay. It returns the squared spread. The formula for variance is given in this way, guys. X minus mu whole square by n. X minus mu whole square by n. So is this similar to summation of x by n? This is the formula for mean. In place of x, we have replaced with x minus mu whole square, which is telling us the dispersion, the spread is getting calculated from the center value, from the mean value. Right? So in order to return only the positive values, we are going with square. Okay. So the disadvantage with going with variance is it returns the squared value. In order to get the original units back, in order to get the original spread, we go with standard deviation. There is a measure called standard deviation. And we use this standard deviation for calculating the actual spread. So this is represented with sigma, which is nothing but square root of variance. Variance is represented by sigma square. Both are same, but the difference between variance and standard deviation is variance returns the squared spread value, whereas standard deviation will return me the original spread. So we consider standard deviation. Now, let us go and calculate these measures in Python. So I have the same data set loaded. Yes. Now let me continue with the measures. I'm going to continue with second moment business decision measures. So I'm going to print the message second moment business decision. Then I'll also print variance. Okay. So I just kept the code very clean and tidy because when someone goes through the code, it will be easy for them to understand what exactly we are doing in each and every line. Okay, so this represents the calculation of variance, then standard deviation, then range in that way. Right. So the function that we use for calculating variance is var. VAR. It is var. So the syntax is same. Data frame object dot column name dot var. So this will return me the variance for sepal length column. Let me see what is the sepal length variance. 0.68. But this is the squared value. We know that there is a disadvantage with variance. It returns the squared spread value. It does not return the actual spread. Right. So in the same way, let me calculate variance for sepal width column. Sepal width 0.189. You just remember these two values. Now let me calculate the standard deviation values one by one. I'll calculate standard deviation values one by one. So let me print standard deviation first of all. The message got printed. Now, in order to calculate standard deviation, we have the function in Python. It is std. std, standard deviation, which returns the original spread value. So the same syntax, data frame object dot column name dot std function, right? So when we go with this line, it returns me the standard deviation for sepal length column. So this is the actual spread in the data. So there is spread, but which is very small, 0.82, not even 1. Now let me calculate spread in sepal width column. By just replacing the column, this will return me the sepal width column standard deviation 0.4. It is very less than sepal width as well. Compared both, if I compare both the values, sepal width, the spread is very small. And finally, I'm going to calculate the range of the columns one by one. But the range function that we have understood as part of data types cannot be used, guys. That is different. But here my requirement is to get the range of the column. What is the formula for range? Maximum value minus minimum value. Right? So how can we calculate maximum value and minimum value of the data? Is there are two functions, max and min. Okay, so max function will be used to calculate the maximum value. Min function will be used to calculate the minimum value. So the difference between these two values will return the range of the column. It returns the range of that specific column. So when I go with this line number 54, the maximum value will be calculated, then the minimum value will be calculated. The difference between both will be calculated and it finally returns the range. So it is 3.6. We can also cross verify whether it is 3.6 or not. How? I'll only calculate max value. First of all, see, 7.9. Now, I'll calculate only the minimum value. Even this is the advantage, guys. If you are using Spider, you can select and you can execute. Only the selected part executes. See, 7.9 minus 4.3. Is it 3.6? Yes. Yes. I hope it is clear. Now, in the same way, let us also calculate range for sepal width column. The same, replacing the column will return me the range for sepal width. 2.4. It is 2.4. So we have calculated the measures of second moment business decision as well. Variance, standard deviation and range. Done. Now, let me go with the next moment. Third moment business decision. What exactly does third moment business decision return us? This is very interesting. Third moment business decision will help us to understand, asymmetry in the data. Asymmetry in the data. What exactly is asymmetry? We'll understand. It tries to capture the direction of spread. Third moment business decision help us to capture the direction of spread. Towards which side we have outliers. Extreme values can be understood using third moment business decision. We can get this information, okay, using third moment business decision. How? Third moment business decision captures the direction of spread from the center. from the center, do we have the long tail towards left hand side or right hand side? So that information will be provided by third moment business decision. And the measure that we calculate in third moment business decision is called skewness. It is called skewness. And this skewness is of generally three types: negatively skewed, positively skewed, and no skewed or normally distributed data. No skewed is nothing but normal distributed data. So if you take negatively skewed data, the relation between the first moment measures will be given in this fashion. Why? For negatively skewed data, you will find the long tail. Okay, the long tail will be towards left hand side. For positively skewed data, you will find the tail towards right hand side. So positively skewed data is also called right skewed data. Negatively skewed data is also called as left skewed data. Okay, so just use the common sense. What is this long tail represents? The long tail is because of outliers. If there are any outliers in the data, extreme values, you'll get this long tails in the distribution. We'll get long tails in the distribution when we visualize it. So because of these outliers, what happens, the mean value gets pulled. Actually, the mean, the median or the mode, they have to lie exactly at the center. And this is called as Z distribution. If you remember the concepts of statistics, okay, there is a distribution called normal distribution. We have studied, okay, that is nothing but Z distribution, okay, which is similar to a bell. If you take a bell and if you just consider only the outline of it, that is representing Z distribution or normal distribution, in which all the three measures, mean, median, mode, will lie exactly at the center. If I cut this curve exactly at the center, I'll get two identical parts. But if I cut it at the center, will I get two identical parts? No. Here there is skewness. Here also there is skewness. This is called negatively skewed data and this is called right positively skewed data. So that is what we can understand. But how can you identify it easily is, as we have the long tail towards the right hand side, the mean value gets pulled towards right hand side. Obviously, we know that mean value is affected, influenced by outliers. So the mean from the middle gets pulled towards its side. So that is why you see the equation. The relation between the first moment measures will be like mean greater than, median greater than, mode. But in case of negatively skewed data, mode is greater than, median greater than, mean. But in no skewed data, all of these three will be seen. And here is the formula for calculating skewness, guys. X minus mu by sigma raised to the power 3. What are X? X are nothing but the data, the values, data points. Mu represents the mean of the value, mean of the column. And sigma represents the standard deviation of the column, the data. Right? So in the back end, the formula gets executed and it returns the skewness. So at least by having the information of mean, median and mode, can I talk about skewness? Yes. If you have all these three values for any given column, we can comment on skewness. Am I right? Yes, we'll compare the values. When you compare the values, you can take a call on skewness. That is what we do. Now, let me calculate skewness, because skewness is the only measure that we calculate as part of third moment business decision. So, as usual, I'm printing third moment business decision, a measure, okay, a message to the console, and I'm printing skewness. In order to calculate skewness, there is a function, it is skew. In Python, we have skew as the function, which calculates the skewness for that specific column. The syntax is again the same. If you observe, the syntax is same. Only the function is being changed for measure to measure. Okay. So data frame object dot column name dot function is skew. So this will return me the skewness value for sepal length column. What do you see? 0.31. Is it positive or negative? It is positive. So that means sepal length is positively skewed data. Where can we have the extreme values? Probably on the right side. Probably on the right side. Then coming to the sepal width column. Let us get the skewness calculated. It is also same. Yes, it is also same. But if you want to visualize the plot in this fashion, you'll understand it in data visualization. Under data visualization, we'll be learning the concept of histogram. Okay, there we can clearly understand the plots one by one. Okay, taking the data, we'll visualize the data. Right. So third moment business decision, it measures the asymmetry in the data. Coming to fourth moment business decision. What does fourth moment business decision captures is, fourth moment business decision actually, it measures the peakedness in the data. It measures peakedness. What exactly is this peakedness? This peakedness gets calculated whether the data has a tall peak or wide peak will be understood. That will be understood by using fourth moment. But what exactly are we going to calculate in fourth moment business decision? Is kurtosis. It is called kurtosis. So the formula for the kurtosis is given in this fashion. So x minus mu by sigma raised to the power 4 minus 3. This 3 indicates the kurtosis value of z. Normally distributed curve that we take z distribution. So the kurtosis value for z is 3. Okay. So if you consider why are we removing 3, you'll understand, guys. Why did we mention 3 in the formula? You'll understand later on. But what is the purpose of fourth moment business decision is, it actually measures the peakedness in the data. Okay, so like how skewness is divided into 3 types, even kurtosis is also divided into 3 types. Positive kurtosis, negative kurtosis, and no kurtosis or normally distributed data. What does positive kurtosis mean? It means the tail will be very peak. Okay, sorry, the peak will be very tall. Whatever you see here, the peak, it will be very tall compared to Z. You are comparing, you are taking reference as Z. Z is taken as reference, right? So that is why we are removing 3. The kurtosis value for Z. In the same way, for negative kurtosis, you will find a wide peak. Okay, instead of finding a sharp peak or tall peak, the peak will be wide. So if you have negative kurtosis data, you will observe that the data is spread across the plot. It is not concentrated at one particular position. Right? Instead of this, you'll have the option like, the data gets spread across the plot. But in positive kurtosis, it is actually getting settled at one particular position. At this position only we have majority of the data line. So that is why we see a sharp peak. There is a sharp peak, a tall peak. And then these peaks, these curves have, technically they are given with some names. The positive kurtosis curve is called leptokurtic. The negative kurtosis curve is called platykurtic. And no kurtosis curve is called mesokurtic. So these are the different names given for, all the three types of kurtosis. I hope it is making sense. Now let us also calculate the kurtosis for, for the columns. I'll use the function curt. The function curt will be used to calculate the kurtosis. Okay, so I'm printing the message. Then printing kurtosis. In order to calculate kurtosis for sepal length column, the same syntax will be used, but I'm just changing the function. It is curt. Curt function will be used to calculate kurtosis. So let us understand what type of kurtosis does sepal length have. You see the value negative, so that means sepal length is having negative kurtosis. It has negative kurtosis. What can you identify from this value? Okay, so that means the data is not concentrated at one point. If it is negative, obviously the peak will be wide. The data is not concentrated. It is spread across the plot. In that way, we'll try to get the insights. The insights will be understood in that fashion, guys. Let us also calculate kurtosis for sepal width column. Sepal width. Here I see the positive kurtosis. So that means a sharp peak, a tall peak is what we get when we visualize, the sepal width column data. Making sense? Yes. So that is a purpose of all the four movements. First movement, second movement, third movement, and fourth movement. We repeat. First movement is measuring the center value. Second movement measures the spread or dispersion or deviation. Third movement measures asymmetry. And fourth movement measures peakedness. Fourth movement measures peakedness. So we understood the measures and the purpose of calculating these measures. But visualizations were not covered, right? Now let us start visualizations. It is graphical representation. So I'll start with bar plot because majority of us are familiar with bar plot. Can you tell me what do we have in bar plot? Yes. Any idea, guys? What exactly do we have in bar plot? In bar plot, we'll have bars. But what is the purpose of bar plot? The purpose of bar plot is to understand data distribution. In order to understand the data distribution, in general, we visualize bar plot. Right? But bar plot has a disadvantage. You know what it is? Bar plot is not a good visualization for large data sets. If you are actually working on large data set, okay, and if you try to visualize bar plot to understand the data distribution, we cannot interpret the results. The reason behind it is the bars get squeezed. The bars get squeezed to lines. you'll have in this fashion. Okay, you'll get the visualization in this fashion, where we'll fail to interpret, where we'll fail to understand the plot. Okay, so that is a disadvantage of visualizing a bar plot. But in general, bar plot help us to understand the distribution of the data, how the data is distributed can be understood using bar plot. Okay, so I'll take an example. We'll practically first of all visualize bar plot, then we'll go to the next plot, guys, one by one. So I'm just changing the code. Yes. The data set remains constant. I'm not changing the data set. Okay, it is iris.csv, but here there are new packages in the picture. You see here, there are new packages. Anyhow, we have already understood the concept of pandas. Why are we using pandas? Pandas help us for data manipulation. Whenever I want to perform manipulations on the data, I will go and use pandas package. So I'm importing pandas for manipulating the data. Okay, and I'm giving a shortcut name, it is PD. I'm giving an alias name, it is PD. Done. So pandas got imported. Pandas got imported. Then next to pandas, I am importing NumPy. NumPy stands for numerical Python. NumPy stands for numerical Python. And the purpose of NumPy is to perform basic mathematical calculations. To handle arrays in Python, we use NumPy. Okay, so I'm importing NumPy package as NP. I'm importing NumPy package as NP. Done. Then next to NumPy, I'm going to import one more package. It is matplotlib.pyplot. Matplotlib.pyplot. First of all, let me talk about matplotlib. Matplotlib is a package used for visualizations. It is used for data visualization. In order to visualize the data, we use some functions. Those functions are readily available in matplotlib. And within matplotlib, there is a sub package. There is a module called pyplot, and this pyplot is what we are importing. I'm not importing the matplotlib, entire matplotlib, but I'm just importing only pyplot. And this pyplot, I'm giving an alias name as PLT. So that makes the difference between line number 1, line number 4. Getting the point? Here we are importing the entire package, but here I don't want the entire package. I just want only a part of it. So whatever is my requirement, I'll just import that specific part. Pyplot is what I'm importing and giving an alias name as PLT. Okay, so why are we importing? For visualizations. Done. Now, again, I'm importing Cborn. Cborn is a package for visualizations again. It is also used for data visualization, but this is an advanced package. It is an advanced package compared to Matplotlib. Okay, so I'm importing Cborn as SNS. So let me do it. Is it done? Here if you see, yes, it got executed. So that means all the required packages got imported. So they are in the memory now. They are in the Python's memory. Now I'll start working on the data one by one. Anyhow, I need not run this line of code. Why? This is my data set, right? Already I have the data set here. In the same variable, I have the data. So I'll skip this line. I'll directly go to info function. What is the purpose of info function? Info function will display the information about the data set. It will display the information about the data set. So let us get the information. Anyhow, we have understood the results of info earlier in the previous code. So the same results is what you see because we did not change the data set. The same data set. Now, let us understand how we can visualize bar plot. So I'm using a function called bar. There is a function called bar. So this bar function is available in PyPlot. The shortcut name, alias name that we have provided for PyPlot is PLT. It is PLT. So PLT dot bar. Like how we are using read underscore CSV from pandas, in the same way, bar function I am using from PLT. Then within the bar function, I am specifying two parameters. What are they? Height and X. So height takes a values and X also takes some values. Height gives the values to y-axis and the X parameter gives the values to x-axis. Where are we passing the data? I am passing the data to y-axis. If you see here, iris underscore data, which means my data frame object. From this data frame object, I want to visualize bar plot only on sepal length column. So that means the values of sepal length column will be given to height parameter. How many values we have for sepal length? 150. What do you mean by 150 comma 5 guys? 150 comma 5 represents each and every column has 150 values. So sepal length has 150 values. The same number of 150 values should be given to x-axis. The same number of values has to be provided for x-axis. If there is mismatch between x and height values, then the plot will not get visualized. We cannot visualize the plot. Okay, so I'll show you. For that, in order to come up with 150 values, I'm using a function called arrange. It is not arrange, it is arrange from numpy, np. From numpy, I'm using a function that is arrange. Okay. Within arrange, there are two numbers 150 comma 151. Sorry, 1 comma 151. So that means it starts at 1 and it ends the sequence at 150. So how many values in total? 150 values. So these 150 values will be given for x-axis. X-axis takes 150 values, y-axis also takes 150 values. So there is no kind of mismatch, and if I execute line number 15, it has to display bar plot. Let us check whether the bar plot has been generated. It has to generate. Yes. Even if you see here under the plots pane, see, were you able to understand anything? Not exactly, right? So this is the disadvantage of bar plot. The reason behind it is when you keep on increasing the number of records, If you are working on large data sets, we cannot interpret the results of bar plot. But the purpose of bar plot is to understand the distribution. And if this is the case, how am I going to interpret the plot? No, right? So that is why, bar plot is not an ideal plot for data distribution. Not to understand the data distribution, bar plot is not generally visualized. Now, let me also try in a different way. I'll visualize bar plot only. I want to visualize bar plot in which I am passing the values of petal length to height parameter, but to the x parameter, I am passing range values. Do you remember range? Data type range. Yes, the purpose of range is to store, sequence of positive integers with interval. So range of 150 will start generating the values from 0 till 149. So 0 till 149 will be 150 values again. So when I execute this, this will also return me a bar plot, which cannot be interpreted. See, I cannot interpret the plots. So this disadvantage of bar plot was overcome by histogram. It was overcome by histogram. Let us discuss about histogram, guys. Right. So what exactly histogram is? Histogram is a visualization which is also used for data distribution. To understand data distribution, histogram is generally visualized. So the disadvantage of bar plot was overcome by histogram, where the data gets converted to bins. The data gets grouped. Okay. So what exactly happens is the data that we have will be converted into bins, groups. So you'll find bins, one to the next. So in this way, you'll find bins. This is a histogram. This is a histogram. But if you observe, how can I interpret the data distribution exactly here is, just take the outline of the histogram. Where do you see the long tail? Towards right hand side. So that means it is positive skewed data. If you see here, I see the left tail. In the second plot, I see the tail towards the left hand side. This is negative skewed data. So by visualizing histogram, am I able to comment on skewness? Yes. What does it mean? There might be chances of outliers, the extreme values being on the left side. Here, there might be chances of outliers towards right hand side. So histogram tells us two things. The primary purpose of histogram is to understand the data distribution, and the secondary purpose of histogram is to comment on outliers. We are not sure. With respect to outliers, you cannot tell that you are 100% confident that we have outliers on the right hand side. No. But instead of telling in that fashion, we can keep our statement in this way. There might be chance of outliers. See, why are you getting a long tail? Because of some extreme values. That extreme value may or may not be an outlier. I hope you are getting my point. So we cannot confirm the outliers by visualizing a histogram is what I'm trying to explain you. But data distribution can be understood. Even if it is a large data, even fine. We can interpret the results. The results can be interpreted. Now, let us visualize histogram, guys. We have visualized bar plot, right? In the same way, let us visualize histogram. Hist is the function. Hist is the function from PLT. What is PLT? Pie plot. Okay. So PLT dot hist, in which we are supposed to pass the data. If we pass the data, this will return me the histogram for which column? Sepal length column. This will return the histogram for sepal length column. Let me do it. See. So this is the histogram. I see that there are some kind of, groups, some clusters. So because of that, there are three different peaks. Instead of, having the data in one single peak, there are different groups, but the long tail is towards again the right side. So probably these values may or may not be outliers. We are not sure. We are not sure. Okay, then let us also get the histogram on petal length column. Just change the column name. We'll get the histogram for petal length. Here I can clearly understand there are two groups, guys. How? You see the gap? So this obviously becomes one group. This becomes the other group. Cluster 1, cluster 2. Cluster 1, cluster 2. So these are the default histograms that we are getting. But can we customize our histogram? Yes, we can customize the histogram. But when you go through the documentation of these functions, all these functions that we are using from the packages, whatever the packages that we use as part of our script, okay, they have the functions, right? So these functions will have documentation. These functions will have documentation. So if you go through the documentation, you can change the values for the parameters. We can change the values for the parameters. Okay, so what am I doing here is I'm customizing my histogram. If you see here, by default, you'll get 10 bins. If you count, you'll get 10 bins by default. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by default, histogram is returning 10 bins. But if you don't want 10 bins, you can customize. And by default is returning me histogram in blue color. If you don't want to get the blue color, you can customize the histogram. But when you can do it is when you go through the documentation of hist function. When you go through the documentation of hist function. So let me come from here, line number 24, plt.figure. So this plt.figure, figure is a function from pyplot which helps us to set the size, dimensions for the figure, 8 by 5. Figure size is 8 by 5, width and height. Width and height. Then plt.hist. So the histogram, in order to get the histogram, we use hist function in which I am passing the data sepal length. I want to visualize histogram on sepal length column. Then I don't want by default 10 bins. I want my bins I have specified here. So how many bins will I get? I'll get only 4 bins. I'll not get 5 bins, guys. From 4 to 5, I'll get first bin. From 5 to 6, I'll get second bin. From 6 to 7, I'll get third bin. 7 to 8, fourth bin. Then the color of the histogram, I want it in red color, but the edges of the bins should be in black color. That is what I have specified. Completely I am customizing as per my requirement. But when you can do it is, time again I am telling you, if you go through the documentation of the function, only then you'll understand these parameters. The values for the parameters will be understood when you go through the documentations. And I want the x-axis label as sepal length. The x-axis label should be named as sepal length. Y-axis label should be named as frequency. Okay. And I want the entire title for the histogram as histogram of sepal length with custom bins. This will be the title. And show function will return the histogram. Okay, the visualization. Let me run all the lines of code together. This will return me the customized histogram. See, sepal length, x-axis, frequency on y-axis, and the overall title, histogram of sepal length with custom bins. Yes. How many bins you see? Only 4 bins. 4 to 5, 5 to 6, 6 to 7, and 7 to 8. Is the histogram in red color? Yes. All of these are in bins got separated in the edge colors are black. Yes. Okay. So in this way we can customize the histogram. I hope you are getting the point. Right? Yes. So what is the purpose of histogram? Histogram help us to, understand the data distribution. The primary purpose is to understand the data distribution. Now, coming to next to histogram, there is a plot called box plot. Very, very, very important plot in graphical representation, EDA. What exactly is this box plot? Box plot is also called as whisker plot. It is also called as whisker plot. Also called as box and whisker plot. It is also called as box and whisker plot. Why it is called as box plot is within a box plot you will have box. That is why it is called as box plot. Why it is named as whisker plot is you will have whiskers. These are called whiskers. Since we have both, it is also called as box and whisker plot. What is the purpose of box plot is? The primary purpose of box plot is to talk about outliers. It tells about the presence of outliers. Box plot is the only visualization which tells us the information about outliers, the presence of outliers or not. So within the data, if you take a data and if you try to visualize the box plot, if the values fall beyond the limits, these are called lower limit and this is called upper limit. If the values fall beyond these limits, they are called outliers. They are called outliers. Now let us talk about the components of box plot. This is called lower limit. This is called Q1. This is called Q2. This is called Q3 and it is called upper limit. Okay. So Q2 is also called as median, the middle value. Q1 represents 25th percentile. Q2 represents 50th percentile and Q3 represents 75th percentile. So this entire box is called IQR, interquartile range, which is calculated by formula Q3 minus Q1. Q3 minus Q1 will return me the value for entire IQR. If I assume the total data is 100% in a column, so that data will be divided into 4 parts. 25 here, 25, 25 and 25. This is how it has to be get distributed. So that means this box will contain 50% of the data. But how are these limits calculated? Again, we have a formula. For lower limit, the formula is Q1 minus 1.5 times of IQR. Once after calculating IQR, I'll use Q1 and I'll substitute both the values. I'll get lower limit. Upper limit is calculated by Q3 plus 1.5 times of IQR. If the values fall beyond these limits, upper limit or lower limit, they are called outliers. They are treated as outliers. And box plot is the only visualization. Okay, it is the only visualization which gives the information about outliers. We can visualize them. We can visualize the outliers. There are no other visualizations which gives the information about outliers with confidence, guys. This is giving us the information with the confidence. I hope it is making sense. Now, let me go and visualize box plot using Python. Yes. What am I doing? I'm going to visualize box plot. I'm going to visualize box plot. Okay. So from which package we are taking this box plot? From matplotlib.pyplot. I'm visualizing box plot from pyplot. And I'm just passing the data. So on sepal width column, I'm going to visualize box plot. Let's see what happens. Do you see outliers? Yes, I see outliers. I see outliers. But you cannot just tell there are 4 outliers. No, you cannot count the circles and tell there are 4 outliers. It is wrong. It gives the information about outliers, but it does not talk about the number of outliers. No. We can say that there are outliers. Making sense? Yes. The same box plot, let me try visualizing using Seaborn. Let me try using Seaborn package. sns.boxplot. See, this box plot is from matplotlib and the box plot that we have in line number 36 is from Seaborn. Let me visualize Seaborn using Seaborn. Yes. There are slight differences, right? Earlier, if you see here, earlier the box is not shaded. But if I use the box plot function from Seaborn, the box got shaded and it is bulged out. Am I right? Yes. So there are some differences between, the basic package and the advanced package. The basic package and the advanced package. But the purpose is same for data visualization. Are we calculating the limits? No, we are not calculating the limits. That is not our task. Everything will be done by the function. In the backend, it will be completed. Right. What am I doing in line number 37? I'm visualizing box plot on petal width column using box plot function from matplotlib. Do you see outliers? I don't see outliers. There are no outliers in the distribution in the box plot. No outliers, guys. I'll try to visualize the same box plot on the same column from Seaborn. So obviously the box gets shaded and it will be bulged. So that makes the difference between, the packages matplotlib and Seaborn. Yes. So what is the purpose of box plot? Box plot gives the information about outliers. It talks about the presence of outliers or not. Right. So far, we have understood only univariate plots. All the visualizations that we have discussed are univariate. Let us also discuss bivariate visualizations. We have bivariate visualizations. Okay, so let us understand these bivariate visualizations. Okay, before that there is one more visualization called QQ plot. What is this QQ plot is? QQ stands for quantile plot. QQ stands for quantile plot. And the purpose of QQ plot is it checks whether the data follows normal distribution or not. It checks whether the data follows normal distribution, Z distribution or not. If it is following the normal distribution, if you see in the picture, in the image, the majority of the data points should fall on this red line. The majority of these points should fall on this red line. If it does not follow, if it does not fall on the red line, it means it is non-normal distribution. If it fall on this red line, it means it is normal distributed data. Okay, so that is the purpose of QQ plot. QQ plot help us to understand whether the data is normally distributed or not. That is what we understand using QQ plot. Why it is named as QQ plot, on x-axis we take theoretical quantiles, which means Z values. On y-axis we take sample quantiles, nothing but the data. So that is why quantile plot, QQ plot. That is how it is named as QQ plot. Okay, right. And the last plot that we have is the only bivariate plot. It is scatter plot. Very, very, very important plot as per graphical representation in the entire EDA, because scatter plot is the only plot which is part of bivariate visualization. And the purpose of scatter plot is to understand the relationship between two variables. If there are two variables, two features, and if you want to get the relation between both the variables, okay, if you want to understand the relation between these variables, we go and visualize a scatter plot. And when we visualize scatter plot, we can understand how well they are correlated. We can understand the relation between x and y, the variables. Scatter plot talks about three main things. One is direction, the second one is linearity, and the third one is strength. Repeat: direction, linearity, and strength. Coming to the direction, it gives the information whether the direction is upward, nothing but positive, or downward, or negative. See, if I take two variables like experience followed by salary, experience and salary. We know that in general, if you have more experience, obviously the salary will also increase. So when you gain good amount of experience, salary also start increasing. So in this case, what is happening? As the value for experience increases, the value for salary will increase. So you will find the direction in upward, the scattered towards upward, nothing but positive. Right? In the same way, direction can also be negative, which means as x increases, what's happening to y? Y decreases. Y decreases. That is nothing but negative direction or downward direction. So scatter plot gives the information about direction. Next to direction, we have linearity. The scatter that you see between the variables, the scatter, is it linear or do you find any non-linear curves? Okay, that can be understood by visualizing the scatter plot. And the third point that scatter plot discussed is strength. Strength is subjective in nature. What exactly strength represents is the scatter that we have here, okay, between the variables, the scatter, the distribution of the scatter, is it very close to each other or separated at a distance or very far from each other? Is what strength decides. Strength is decided based on the scatter spread, the spread of the scatter. And this strength is subjective in nature. It is subjective in nature. Strength is of three types: strong, weak, and moderate. If the scatter is tightly packed, if it is close to very each other, then we say strength is strong. Strength is strong. If the scatter is loosely packed, if it is separated at a far distance, we say strength between the variables is weak. Between these two cases, we say strength is moderate. But strength being subjective, what do you mean by subjective? Means I visualize the scatter plot, and if you are also visualizing the same scatter plot, I can come with my decision, you guys can come with your conclusions. That is what subjective means. Subjective is actually referring to all of us will have their own perceptions. They can come with their own conclusion. That doesn't mean, see, if I say this is strong and if you say this is weak, moderate, I cannot tell you are wrong. No, both of us are correct. The reason behind it is subjective. Strength being subjective, we cannot decide whether it is strong, weak, or moderate. In order to quantify strength, our statisticians have come up with a measure called small r. Small r, what it is called? Correlation coefficient. It is called as correlation coefficient. And this correlation coefficient helped us to quantify strength. You know how? Based on the value of r, we have the thumb rules. R greater than 0.85. If R greater than 0.85, we say the strength is strong. If R less than 0.4, we say strength is weak. If R is between 0.85 and 0.4, we say strength is moderate. So these are the thumb rules that we have defined, the statisticians have defined to quantify the strength between the variables. I hope it is making sense. Now let us visualize scatter plot by taking two columns at a time, and you guys have to tell me the strength. Okay, so what I'm going to do here, I'm coming up with a figure function. So figure function from PLT, matplotlib.pyplot. Okay, so this will create a figure of size 10 by 8. Then I'm using the function scatter from pyplot, which is going to return as a scatter plot, where x-axis takes petal length, y-axis takes petal width, and the color of the scatter will be green. By default, it will return in blue color. I don't want it in blue color. I want to change it to green. So the X label I'll keep it as petal length, Y label I'll keep it as petal width, and the title is correlation between petal length and petal width. And plt.show function will return the scatter plot, guys. It is going to display the plot. See, you see here, this is my scatter plot. Let me right. So this is my scatter plot. Now you take a call. Tell me the direction for this plot. Tell me the direction first of all. As petal length is increasing, what's happening to petal width? Direction. It is upward. If you see here, as petal length is increasing, petal width is also increasing. Upward, positive direction. Is it linear? Yes, it is linear. But I can clearly see there are two groups. This is one group and probably this might be the other cluster. Cluster 1, cluster 2. I can clearly see the difference, the gap. But can you comment on strength? Comment on strength. Is it strong, weak, or moderate? What exactly is it? The strength. Is it strong, moderate, or weak? What do you see? Okay. Moderate is what my friend says. Strong, good. Keep going. Moderate or strong or weak? Even I feel it is as moderate because I see the scatter is not tightly packed. Okay. But also there is a gap. So I feel it is moderate. But the problem with the strength is subjective in nature. So I cannot directly rely on by taking the decision, right? So how can I finalize it? By calculating small r, right? So in order to calculate small r, we have a function in Python. It is CORR, correlation coefficient. Correlation coefficient. So when I use CORR on the entire data frame, it will return me a matrix. It will return me a matrix. What is a matrix? Matrix is a two-dimensional object which contains rows and columns. Yes, even we feel the same. Scatter is having gaps, so we feel it as moderate. But we cannot confirm, we cannot finalize it until unless considering the small r values. So the correlation coefficient values will be returned by using CORR function. See, you will get a square matrix, guys. You know what do you mean by a square matrix? The number of rows and the number of columns will be same. So what exactly you will find here is the same rows and the columns are same. Okay. And the diagonal values will be 1 because the diagonal values are representing the correlation between the same variable. Correlation between sepal length and the sepal length is 1. Sepal width and the sepal width is 1. Petal length and petal length is 1, obviously. So we have to consider either the upper triangle values or the lower triangle values. So we are checking the relation between petal length and petal width. Petal length and petal width. So that means this value is what I have to take. Now can you finalize? R value is 0.96. So what is the strength? Strength between petal length and petal width is strong. It is strong. So in that way, we have to finalize strength. By considering the small r values, we finalize the relation, the strength between the two variables. I hope it is making sense. Can you tell me the relation between sepal length and petal length? The relation between sepal length and petal length. By looking at this matrix, correlation coefficient matrix, tell me the relation between sepal length and petal length. Even in the case of sepal length and petal length, the relation is, the strength is strong. If you observe here, this is sepal length and this is petal length. The value is greater than 0.85. Yes, it will be strong. So that is how we decide the strength value in scatter plot. Not just visualization, not just visualizing the scatter plot. The strength has to be decided only after visualizing small r. Right. So this marks the end of EDA. We have understood the concepts of 4 moments as well as data visualization was also covered. Okay, where we have understood both univariate and bivariate plots. The only plot under the bivariate is scatter plot, bivariate plot. Okay, so in the next class, we'll be understanding the techniques for data cleaning. Okay, so Right. So coming to the next topic, where we have in the flow crisp-mlq. Within the crisp-mlq, there are in total 6 phases. Yes. So what are the 6 phases? Business and data understanding, data preparation, model building, model evaluation, model deployment, and finally we have monitoring and maintenance. Right. So as part of phase 2, we have data preparation. We have data preparation. Within this data preparation, there are 3 subphases. What are they? What are the 3 subphases that we have? EDA, exploratory data analysis, data cleaning or data cleansing, and finally feature engineering. So as we complete EDA, where we calculate first moment, second moment, third moment, fourth moment, and visualizations, we'll get the insights from the data. We'll get insights from the data. So these insights will be shared to the client. We'll share these insights to the client. And client takes respective actions. Okay. So that is the purpose of EDA. We are performing analysis on the raw data. Now, post completing EDA, we'll start with data cleaning. So under data cleaning, we'll generally have 9 steps, guys. There are 9 steps. Okay. What are the 9 steps that we have under data cleaning? They are typecasting. So typecasting is a technique where we use to convert the data type from one to other. If I want to convert the data type from one to the other, we use typecasting. Then handling duplicates. If we have duplicates in the data, we are supposed to remove them. So the duplicates will be identified and we'll also remove the duplicates. Then the third step under data cleaning is outlier treatment. The outliers that we have within the data will be treated. Okay. So in general, how we are visualizing the outliers? Using box plot. Box plot is the only visualization which gives the information about the outliers. The presence of outliers or not. Yes. So these outliers, if you have outliers in the data, they are supposed to be treated. Then next to outlier treatment, we have zero and near zero variance. We have understood variance concept. Yes. What exactly is variance? Variance is representing spread from the center. If the data does not contain any spread, okay, if the variance is zero, what is the purpose of continuing with that column? So what we do is, we remove such kind of columns. Such kind of features will be eliminated. Then next to zero and near zero variance, we have discretization. Discretization is also called as binning, grouping. Okay. So We'll remove the columns. Okay, we'll convert. Discretization is nothing but, if you have any continuous data, this continuous data will be converted to discrete data, the fixed data. Then next to discretization, we'll have dummy variables. Dummy variable creation. So we create dummy variables. We create dummy variables. And this includes conversion of non-numeric columns to numeric columns. What is the purpose of creating dummy variables? We'll understand. Should we create dummy variable every time? Not exactly, but there might be some cases where the non-numeric columns are very important. Okay, so if the non-numeric columns are very important, so if we want to include these non-numeric columns in the analysis, then you convert into numeric columns. These are called dummy variables. We'll understand one by one. We'll understand what is the purpose of converting. Why should we convert? We'll understand. Next to it, we have, next to dummy variable creation, handling missing values. So because of multiple reasons, there might be chances of missing values in the data. The missing values can be present in the data. Okay, so we'll try to perform imputation. Imputation has to be done, right? So next to handling missing values, we'll have transformations. We have transformations. What exactly does transformations do is, transformations include converting non-numeric data. If you have any data which is non-normal, okay, so if the data is non-normal, we convert this non-normal data to normally distributed data. Earlier we have discussed QQ plot, quantile plot. So initially we'll visualize this QQ plot. Okay, then after visualizing this QQ plot, if I found that the data is non-normal, if it is not following Z distribution, then I'll apply transformations. Like where we have manual transformations, as well as we also have automated transformation techniques. We can apply log transformation, exponential transformation, Box-Cox, Yo-Johnson. Okay, so different transformation techniques are available. We use these techniques and we perform transformations. The data gets transformed. Then finally, feature scaling. The features that we have needs to be scaled. The features, nothing but the columns. The values, the data within the columns has to be scaled. All the values, they have to be brought to a particular scale. Why should we bring to a particular scale? What is the reasons behind it? What if I don't perform feature scaling? We'll understand one by one. Right? Yes. So once after completing the data preparation phase, we'll go to the model building phase where we create the model, the equation. Okay. We'll create this model. The model gets built. We use any algorithms like machine learning or deep learning algorithms will be used on the data, and the data gets trained. to build this equation. This equation is called model. And this model help us to predict the new data. I can perform predictions. I can get the predictions on the new data. Okay. Even we have sessions on machine learning and deep learning algorithms. We'll understand how the model is getting trained. Initially, we'll take the historical data and we'll pass it to the algorithm, okay, where this model gets trained. Initially, the model gets trained on the historical data. We'll pass both inputs and output. When we pass both the inputs and output, we'll identify that the model gets trained, and once after training the model, we'll use it for predictions. We'll use it for predictions. Once if the predictions are coming in the right way, then we'll also check the evaluation. We'll evaluate the model with some metrics. There are multiple metrics. So upon the use case, we'll evaluate the model's performance using metrics. And finally, the model will be deployed, guys. To the production, the model gets deployed. And this model, post deploying, the client starts using this model on the new data. So for the new data, there is no output. No output. This output will be predicted by the model. I hope it is making sense. And what is our task post deployment? We continuously monitor the results. We'll monitor the results, and if the results are not up to the mark, okay, then we go with maintenance. We'll do preventive maintenance for the model. By taking the new data, we'll retrain the model. Once after retraining, the process again continues. We'll check the performance, the evaluation metrics, then the deployment. Again, we'll start monitoring the results. This is how the end-to-end life cycle of an AI or a machine learning or deep learning application be like. If you are coming up with any of these applications, you should obviously follow a methodology. A methodology has to be implemented. Okay, so I hope the concepts of EDA are clear. Exploratory data analysis. Right? Yes. If you have any kind of technical questions, feel free to ask questions on the topics that we have covered, or even if you have any other questions, yes. So any questions related to the topic? Any questions? If you find that the session went well, hit on the like button. It's a kind of encouragement that you're going to provide from your side. Thank you so much for your feedback. In the same way, if you have any kind of questions, please feel free to ask questions, guys. Yes, the feedback link has been provided. Please provide your valuable feedback before you leave. And thank you so much for giving your valuable feedback.